25 degrees Celsius and 1 atm, that is atmospheric pressure. A gas occupies a volume of 1.50 dm cube. What volume will it occupy at 100 degrees Celsius and 1 atm? Solution. This is a question on gas laws, and here we'll be applying Charles' law. Why? This is because the pressure of the gas here is being constant. Looking at the question, at 25 degrees Celsius, the pressure is 1 atm. And also when the temperature is changing to 100 degrees Celsius, the pressure is still 1 atm. Then we can say that the pressure is being kept constant. And according to Charles' law states that the volume of a fixed mass of gas is directly proportional to its temperature, provided the pressure remains constant. So this makes Charles' law applicable in this case. And for Charles' law, the equation derived from Charles' law is V1 over T1 equals V2 over T2. Here, subscript of 1 and 2 is referred to as the initial value and the final value. That means V1 is the initial volume of the gas, T1 is the initial temperature of the gas, V2 is the final volume, while T2 is the final temperature of the gas. Now, having written out the equation we'll be using in solving this, the next thing to do now is to write out the values given from the question. I do this most of the time so as to make it easier to get the unknown. So now let's proceed. V1 here, that is the initial volume of the gas. Based on the question, you are made to understand that the gas occupies a volume of 1.50 dm cube. So that means V1 is equal to 1.50 dm cube. Then T1, that's equal to 25 degrees Celsius. So now for gas laws, temperature is always calculated in Kelvin. So that means we'll be converting degrees Celsius to Kelvin, and to do that we'll be adding 273 to whatever value we have in degrees Celsius. So that means 25 degrees Celsius will be equal to 25 plus 273. The unit Kelvin, which is equal to 298 unit Kelvin. So now that's the initial values. Now for the final value, now we have V2 to be unknown. Then T2, that is the new temperature of the gas now, is 100 degrees Celsius. So converting 100 degrees Celsius to Kelvin as well, we'll be having 100 plus 273 unit of Kelvin. So 100 plus 273 gives us 373 and the unit Kelvin. So that means T2 is now 373 kelvins. So since V2 is the unknown here, then it is easy for us to find V2, and we do that by making V2 the subject of the formula here that we are using. So here we say V2, and we cross multiply. V2 will be equal to V1 times T2 divided by T1. So the next thing to do now to get V2 is to substitute the values from what we've written above here. So now we say V2 equals V1, which is 1.50 dm cube, multiplied by T2, which is 373 kelvins, divided by T1, which is 298 kelvin. So multiplying the numerator, we have 559.5, and the denominator is still 298. The unit dm cube. So this gives us 1.88, and don't let's forget the unit dm cube. So this serves as the final answer. That means we've gotten V2 to be 1.88 dm cube. And according to the question, we can say that the volume the gas will occupy at 100 degrees Celsius and 1 atmospheric pressure is 1.88 dm cube. And that will be all on that. Kindly subscribe and also click on the notification bell so as to be notified as soon as new videos are being posted. Thank you.